Welcome to problem 8, the last one on the practice exam. So here, this is another thingy and ramp problem. Here I push an object toward a ramp. There is friction. And it encounters the ramp here, goes up, and then comes back down. So the two parts of the problem, right? So parts A and B ask you to find the acceleration on the way up. Part C and D ask you to find the acceleration on the way down. And part E, I believe here is just phrased, why are they different? Without doing any math. And so we'll do part E first. When the block is sliding up the ramp, friction opposes the sliding. So on the way up, friction points down, as does gravity. So on the way up, friction and gravity are both trying to arrest the object's motion. But on the way down, friction points up the ramp. So on the way back down, friction is trying to make it go faster, and gravity is trying to make it go slower. So on the way up, friction and gravity are working together. But on the way down, friction and gravity are working at cross purposes. So if we have our normal rotated coordinate system, friction and gravity are the only forces in the x direction. And on the way up, they work together, and on the way down, they oppose. So we expect the magnitude of the acceleration to be bigger on the way up than on the way down. So we've already done part E. That was easy. So let's now do parts AB and CD and figure out the accelerations. So on the way up, and we're going to do this with our eraser, right? I'm going to draw the force diagram, and then we're just going to erase an arrow and redraw it. So on the way up, what forces do I have? I've got, as always, gravity going down. I've got a normal force like this. And if I am on the way up, friction goes in opposition to motion. Now I need to decompose gravity into its components, as always. So you know the angle. So this one, let's see, that's theta. So this one's going to be mg cosine theta. This one's going to be mg sine theta. Hopefully you've done this a dozen times before. So here are our coordinate axes. So we need F equals ma in both x and y. So in the x direction, I've got, let's see, the only forces are negative, right? Friction pulls me back down. So does gravity. So the force of friction is going to be minus mu k Fn minus mg sine theta equals max. And then in the y direction, again, just read it off the diagram. I've got the normal force minus mg cosine theta equals may. But in the y direction, there is no acceleration. So that is 0. So now we do math. We're going to solve for the normal force and plug it in here. So this tells us that the normal force is equal to the component of the weight perpendicular to the slope, which you could probably expect. And then substituting this in here, I have minus mu k mg cosine theta minus mg sine theta equals max. So, as often happens when things are just being driven by gravity, all the m's cancel. So this m, and that m cancel. And I get, for going up the ramp, an acceleration of minus g sine theta minus mu kg cosine theta. So we just did the acceleration going up the ramp. And I keep dropping my chalk. Nobody has any questions? So now let's figure out what's going on down the ramp. So I'm going to do this with my eraser. I'm just going to change things. So now for parts C and D, the only thing that's different about my force diagram is now the force of friction points up the ramp. All right. So what does that change? Remember, if I'm going down, so now I'm going here, right? So now if I'm sliding down, friction points up the ramp. So that changes that sign. That's the same. That changes this sign, which means that when I'm going down the ramp, the acceleration is minus g sine theta plus mu k g cosine theta. Because when I'm going down the ramp, I'm being opposed by friction. So these have opposite signs. So that's the practice exam. Sajad, I'm going to answer that question as soon as I get off of the recording for YouTube. Are there any questions further about the practice exam? Any of the 8 problems? We'll talk about those now, and then I'll take people's other random questions like yours, Sajad. All right. I think that's all people have about the practice exam. So I'm gonna sit down. Let's see.